Scientific notation is something that is used to represent numbers that are very, very large or very, very small. Numbers that often occur when we're studying science. Specifically, a number is written in scientific notation if it is written as the multiplication, the product of a number between 1 and 9.9999 and a power of 10. So here's an example. I have the number 300 billion. And to write that in scientific notation then, I would write it as the multiplication of 3, because that's a number between 1 and 9.9999, and a power of 10. Because remember, powers of 10 add zeros or move decimal spots. And so 3 times 10 to the, since I have 11 zeros here, I know that's 10 to the 11th exponent. And so 3 times 10 to the 11th is the scientific notation for this number. In your calculator, let me just bring this in. If I were to type in this number, and press enter, I would see the calculator display 3e to the 11th. This is scientific notation. This means, it doesn't mean 3 to the exponent 11, it means 3 times 10 to the exponent 11. Alright? You can also enter numbers directly in scientific notation via this button here. The one I'm circling is the EE button. I could type 3, second function EE, so that means times 10 to the, and then the 11th exponent. Alright, here's a small number, perhaps representing something microscopic in science, something of that nature. And so we want to write this in scientific notation. So this is going to involve the use of a negative exponent on the powers of 10, because remember, 10 to the second, while that's 100, 10 to the negative 2 would be 1 over 100, which is 0.01, which is moving the decimals in a way that's going to create a small number. So this number in scientific notation would be, we'd have to work with the 2 times 10, and so if we want to put the decimal spot there, and it's really back here, 6 spots, my exponent would be negative 6. 2 times 10 to the negative 6, which is 1 over 10 to the 6th, which is 2 times this number being 0.000001, would give me my original number. So this is the scientific notation for my given number. Let's just type it in the calculator to confirm. 0. And there you go. The reason that we often use scientific notation is because numbers can get so large that we can't enter them in normal form into the calculator. So we can work with scientific notation in actually doing our calculations. So let's just pretend we're going to... So let's just take these two numbers and let's say multiply the two numbers together. Instead of working with them as actual numbers written out in a regular form, let's use their corresponding scientific notations. So this number we said was 3 times 10 to the 11th times, this number was 2 times 10 to the negative 6. And now I can use my understanding of exponents to multiply these. 3 times 2, that would be regular 6. And then when we multiply powers of 10, powers with the same base, we add the exponents. So the answer would be 6 times 10 to the 5th in scientific notation, which in regular notation would be 600,000. Okay, let's just check this calculation with the calculator. So I'm going to enter this in scientific notation. I have 3 times 10, so second function times 10 to the 11th, multiplied by 2 times 10 to the negative 6, and my calculator says that the answer is 600,000. Alright, here is a more complex scientific notation problem. We're going to do this both by hand first, and then we will do it and check it with the calculator. So I'm multiplying two numbers and dividing by two other numbers that are multiplied. So I got to work with the numerator first by order of operations. So I can multiply these two numbers by first multiplying 3.6 times 2, which would be 7.2. and multiply the powers of 10 by adding the exponents, which would be 10 to the 12th. And we're going to divide by, again, we're multiplying these four things on the bottom, so the order in which we multiply them doesn't matter since it's all multiplication. So 3 times 5, and multiply the powers of 10, I would add the exponents. Alright, so to proceed from here, we're going to divide 7.2 divided by 15. 7.2 divided by 15 would be 0.48. And dividing powers of 10, 12 subtract negative 8 would be 10 to the 20th. And my answer is looking like it's in scientific notation, but we have one issue, and that's that this number is not between 1 and 9.9. It's a little too small. So what I'm going to do is I'm just going to take this number on its own, just the 0.48, and I'm going to write it as 4.8 times 10 to the... I need to move the decimal one spot over from where I have it to where it actually is. And since we have a smaller number, that would have to be a negative 1 exponent. And then multiply my 10 to the 20th exponent. Multiply these powers of 10. And so we get 4.8 times 10 to the 19th. It's a very large number. A number that on its own would not fit in the calculator in regular notation. Let's check our calculation with the calculator. Entering in the top 3.6 times 10, so second function EE to the 16 times 2 times 10 to the negative 4, close up that bracket, divided by 3 times 10 to the third times 5 times 10 to the negative 11. Close up the bracket, and we see that matches our answer, 4.8 times 10 to the 19th. Just to end off, here's a problem involving scientific notation. The mass of a single carbon atom is very, very small, 1.05 times 10 to the negative 25. So just remember, this number is 0.24 zeros, and the 105. That's what 1.05 times 10 to the negative 25 is, a very small mass. And we want to know how many atoms there are in 1 kilogram of atoms. So we need to know how many of these will fit into this. So this is a division question. We're going to need to go 1 kilogram divided by 1.05 times 10 to the negative 25 kg. And let's just pop this directly into the calculator. This should be a lot of atoms. 1 divided by, bracket, 1.05 times 10 to the negative 25. So 9.5 times 10 to the 24th atoms.